Continuing on in section 1.3, an inequality is a mathematical sentence that compares the values of two expressions using an inequality symbol. Less than, greater than, less than or equal to, or greater than or equal to. So we want to know what's an inequality that compares the numbers square root of 7 and 4 and 1/3. Here it's going to be helpful to get them into a comparable form. So rather than having a square root and a mixed number, I'm going to switch them both to decimals. The square root of 17 is approximately 4.12. 4 1/3 is 4.3 repeating. And to figure that out, guys, we take 1 divided by 3. So if we compare, our 4's are the same, but 1 is less than 3. So our relationship here is less than. And when we compare, we always want to compare the original exact values that they gave us. So square root of 17 is less than 4 1/3. Feel free to pause here and give this a try if you'd like. When we figured this out here, again, the 11.52 is already in decimal form, but our square root of 129 is not. So if we take the square root of 129, I get approximately 11.36. Now, if I can compare them, my 11s are the same, but 3 is less than 5. So since 36 is less than 52, I have the square root of 129 is less than 11.52. Okay, so get them into a comparable form and then compare your digits. What's bigger, what's smaller? Here we have more than 2 items, so we're not going to be able to use a less than and a greater than. So in order to put these in order from least to greatest, a number line is going to be helpful. So to figure out what numbers need to go on our number line, it's helpful if we know what values we're dealing with. I'm going to switch them all to decimal form so that they're comparable. Square root of 4 is 2. 0.4 is already a decimal. 2 divided by 3, or negative 2/3, is 0.6 repeating, and that's negative. Square root of 2 is about 1.41, and I have negative 1.5. So my highest value here is 2, and my lowest value is negative 1.5. So I need to go from negative 2 I'm going to go to 3 just to give us a little bit more there. I'm going to graph each of these points individually. So the square root of 4 is 2. So at 2, I'm going to put a point, and I'm going to label it square root of 4. Again, we want the exact values that they gave us. 0.4 is in between 0 and 1. It's a little bit closer to 0. And these don't have to be perfect, guys, but get them as close as we can. Negative 2/3, or negative 0.6 repeating, is in between 0 and negative 1. But closer to negative 1, 2/3 the way there. Square root of 2 is about 1.41, so in between 1 and 2, a little bit closer to 1. And negative 1.5 is in between negative 1 and 2, right in the middle. So plot each point individually. Once you have all your points, then they're in order from least to greatest. So negative 1.5, negative 2/3, 0.4, square root of 2, square root of 4. And there's our values from least to greatest. Same idea here. Feel free to pause and give this a try if you'd like. The first thing I'm going to do is switch them all to the same form. So since I have some square roots here, some fractions, and some decimals, I'm going to put them all in decimal form. 3.5, negative 2.1, those are already in decimal form. Square root of 9, we know, is 3. Negative 7 over 5 is negative 1.4. And to get that, just take 7 divided by 5 and make it negative. Square root of 5 is approximately 2.24. So if we look here, our biggest value is 3.5. Our smallest value is negative 1.4. So on my number line, I need to go from negative 2 to 4. And it's okay if you have more values, guys. Let's say we started at negative 3. That's okay. But you have to have at least these numbers in order to fit our values. So 3.5 is in between 3 and 4, right in the middle. And again, label it with the exact values they gave us. Negative 2.1 is in between negative 2 and negative 3. Sorry, I needed a negative 3 there. Put your point and label it 3 for square root of 9, negative 1.4 between negative 1 and negative 2, a little bit closer to negative 1. But again, we want to label that the exact answer, so negative 7 over 5. And square root of 5 is about 2.24. So I already have these in order. So if I wanted to list them from least to greatest, I'd have negative 2.1, negative 7 over 5, square root of 5, square root of 9, and 3.5. From least to greatest there. Quick recap here. The definition of a square root can be used to find the exact square roots of some non-negative numbers. The square roots of other non-negative numbers can be approximated. Numbers can be classified by their characteristics, and some types of numbers can be represented on the number line. And that's all I have for section 1.3.